Is sex, age, and race in the United States. So, in this project, some of my major points of interest included how suicide rates are affected by people's sex, age, and race. The goal was to determine which, if any, of these factors had a significant impact on suicide rates in the United States. So, I chose three data sets. My first one was an XML file with death estimates per 100,000 people from 2014 to 2018, and it was separated according to sex, age, and race, which is what I wanted. My second one was an HTML URL with a chart on the page expressing percent changes in suicide rates from 1999 to 2017 for males and females of different races and age groups. And my last data set was a JSON file with estimates of deaths per 100,000 people from 2014 to 2018, which I ended up cleaning later down myself, separated by sex, age, and race. It was similar to the first data set. And some of my expectations were, these are just some hypotheses, where in analyzing the data, I expected to find age would have the largest impact on suicide rates, while men would tend to have higher suicide rates than women. And then in regards to race, I was expecting to find that minorities might tend to experience higher suicide rates. So in my data cleaning process for my first data set, I found that the XML file was rather hard to parse through because each row had a unique ID, so it was impossible to parse by row right off the bat. I had to include multiple nested for loops in order to be able to access that data. And then I actually cleaned the data by only keeping rows which directly correlated to the factors I wanted, the age, year, race, and sex. And then I removed rows before the year 2014 because I only wanted to have the most relevant data. And then I removed several columns that had like extra identifying information, like indicators, unit num. They were all used to reference the data, but they didn't provide meaningful statistics on their own. And for the second data set, I used Beautiful Soup to access the HTML URL. And from there, I just narrowed down the readable data to the table I wanted using the class. And because the table had multiple subheaders, I had to recreate the column names myself and parse through the table tags. And I only appended the rows with information in all three columns that I wanted to a new dictionary. There are fewer inconsistencies in this data set. Some of the column names had like an extra number at the end of them, and I just had to use some regex to remove those random numbers at the end of the row names. And then I removed entire rows from the table if they didn't have data for a specific age or race, because there were some without data. And for the third data set, I opened a readable JSON table because it was a JSON file, and I wrote it to a new CSV file. I created my own header list just to simplify things, and the condition I had to follow was if row of 12 equals 5, and this was because this column specifically was used as an identifier in the original data set, and it correlated to rows only separated by sex, age, and race. So I simplified it down to that, used only those rows. Then I further simplified the data down by ensuring only years 2014 and above are included. And then finally, I wrote those columns to the new CSV file and I closed it. And here are my data analysis and visuals. So this is my first one. It correlates age to death estimate per 100,000 deaths. And as you can see, as you get older, the death estimate definitely does increase. And for the younger ages, it's pretty variable. It has a larger spread. And for our second one, this was the average deaths per 100,000 people of white men, black men, American Indian men, and then the same but for females. And you can see males in general definitely have higher suicide rates, but white males in specifically had a higher average mean than the rest of them. And for my third data analysis, I have the percent change in suicide rate from 1999 to 2017 for males and females, and this was separated by age group. And you can see definitely the younger age groups have had a much more significant change over these last years than the older age groups, with females showing a higher increase in percent change. So some of the biggest insights I gained, I definitely used a lot of Beautiful Soup and I had to create a pandas data frame with my available information. This part gave me a lot of trouble as I hadn't had much experience previously cleaning data straight from the URL. So I had to use the inspect element, find the table tags, and find the table header tags that I actually wanted, and then go from there. And then a big problem I had in my XML file was actually accessing the individual rows. Because it was a poorly set up file, each row was separated by a row ID instead of just a row tag. You couldn't access the rows on their own. You had to do multiple nested loops so you could actually get into the body and then into the specific rows that you wanted, and then use the .t text function to actually get the data from the row. And then in creating my data visualizations, I learned how to create a multiple bar graph, and you had to create a trace for each y value correlate because you had two y values for each x value. And the hard part definitely was formatting this graph because at first it was horizontal and I had to change it to vertical, and then I had to learn about the offset of the graph because the bar graphs were set too much to the right or they would overlap. So I definitely had to learn a lot about how to uh, fix those to be able to go next to each other. And this project, it definitely gave me a much deeper understanding of pandas data frames. I was definitely heavy usage of that, creating tables and visualizations, and then cleaning data so the unnecessary filler was left out. Thank you. Wait, what?